Okay, this is the last video for today's notes. It's been a long day, hasn't it? So sorry, I'll get through this one as fast as possible. We're going to deal with some composite volumes, which really means we're going to put multiple shapes together. And the idea here is the same as we would do with composite shapes whenever we're doing area. It's the idea that if I can find the volume here of the cylinder and the volume of the cone, then I'm just going to add those things together. So I got 3 example problems I'm going to do, varying levels of difficulty. Okay, each one has its own little tricks and twists, but I just want you to see a lot of examples here. Okay. So what I'm going to do here is I'm going to find first the volume of the cylinder at the bottom, and I'm going to find the volume of the cone. I'm going to add those values together, and that'll give me the total volume, right? That's the idea here. The volume of the cylinder, area of the base times the height, right? So the area of the cylindrical base times the height of the cylinder is what I'm interested in. The cylinder's base is a circle with a radius of 24, so that's pi r squared. That's pi times 24 squared. That should give me the area of the base, right? 24 squared, by the way, is 576. So that's 576 pi's for the base. The height of the cylinder portion is 18 yards. So I'm going to take this area of the base, I'm going to multiply it by 18. I'm going to take 576 pi's, I'm going to multiply it by 18. 576 pi times 18 is 10,368 pi's is what I have total for the cylinder. You can't see that, can you? Here we go. So there is the volume of the cylinder. One step down. Second portion, I'm looking at the cone, okay? The cone has a base that's a circle and a height of 9 yards. So what I'm going to do, the only difference between the cylinder and the cone is I need to divide by 3 when I get this base times height thing, right? So pi r squared would be pi, its area of the base times height over 3 for the cone. So I have pi times 12 squared for the cone, pi r squared, that's the base. Multiply it by the height of 9 yards. But then I'm going to take that number and I'm going to divide it by 3 because it's a cone. Well, 9 over 3, that's nice because that reduces 3 over 1. 12 squared is 144, so I need 144 times the 3 here. 144 times 3 is 432 pi's. 432 pi total for the cone. I've already divided by 3. So I've got 10,000 pi's for the cylinder. I've got 432 pi's for the cone. If I add those together, that gives me a grand total of 10,800 pi's. This is in cubic yards, right? And I could actually multiply it out if I wanted to. If I took it times pi, it'd be 34,000 or so total cubic yards. That's a big thing. It's a big cylinder with a cone on top. But the idea there hopefully makes sense. I'm going to find the shapes individually, their individual volumes. I'm just going to sum them. I'm going to add them up. Let's do another one here. Okay. Here we have a rectangular prism, but it has like a pyramid that's cut out of the top, right? So this is going to be like a subtraction problem. First steps first. Let's go through and let's find the volume of this prism, and let's subtract the volume of the pyramid. This is going to be a subtraction problem, right? Well, the volume of the prism, that's pretty easy. That's 25 times 12. It's length times width times height, right? You guys have done that before. But it's area of the base, which is 25 times 12. Okay? Area of the base is 25 times 12, which is 300. So that's the rectangular base. Multiply that by 15, and that gives me the volume of the prism. 300 times 15 is 4,500. I'm going to take some of that away, okay? So this is 4,500 for the volume of the prism. I'm going to take away the pyramid now. Okay, the pyramid. Well, this is interesting. Hold on. The base of the pyramid is at 25 times 12 again, right? So it's 300. The height of the pyramid, from the middle of the pyramid down here, well, isn't that just the 15 feet again, right? So wait a second. I've got area of the base is 300 times 15 is 4,500. The area of the pyramid, it's going to look a lot like the area of the prism, isn't it? The area of the base is 25 times 12. The height of the pyramid is still 15, but I'm going to take that number, I'm going to divide it by 3 because it comes to a point. So 4,500 divided by 3, that's 1,500. Okay, so if I take 4,500, I take out the pyramid, 1,500, I'm left with 3,000 cubic feet. Interesting idea there, right? If I take a pyramid that has the same dimensions as the prism, except it comes to a point, right? I'm going to take 1/3 of the prism away. That's all I'm doing. I'm left with 2/3 of that original value because I took 1/3 away. Okay, one more. The idea here being I can add shapes, I can also do subtraction, right? One more, okay? This one looks like an addition problem to me. This one looks like I need to take the volume of the prism and add in the volume of the triangular prism on the top. That is not a pyramid. It comes to an edge, not a point, right? So let's do the volume of the prism on the bottom. That is an 8x4 base, right? This is an 8x4 base. So the area of that base is 32 units. I'm going to multiply it by the height of this prism, which is 5 units. 32 times 5 is 160. So I've got 160 cubic centimeters, so I shouldn't have circled that. That's the rectangular portion down at the bottom. Now I need to add the triangular portion at the top. A little bit tougher here, okay? You'll notice, by the way, this is an 8x8x8 triangle. So I'm going to consider this blue portion here, this face, this front face of the triangle, that's going to be my base, right? Well, I need to find the area of that triangle. Turns out, I have 8 and 8 and 8. I need the height, so I can do 1/2 base times height, right? Well, this looks like a familiar problem because we've done this already in the notes today. I've got 4 and I've got 8. That's an equilateral triangle, so I know that this is 60 degrees down here. It's a 30, 60, 90 triangle. How do I get from the short leg to the long leg of a 30, 60, 90 triangle? I tack on a square root of 3. That's 4 square roots of 3 for the height. So that means the area of the base, the area of that triangular base that I'm going to take and I'm going to extend out back into the picture is 1/2. The base of this triangle here is 8 units. And the height from here to here is 4 square roots of 3. 1/2 of 8 is 4. 4 times 4 is 16. That's 16 square roots of 3 would be the area of the base, the area of the triangle. Now, how deep is it? How far do I go back this direction? Well, that would be 4 centimeters, right? So that means the volume is going to be 16 square roots of 3, but I'm going to take that, I'm going to multiply it times 4. That gives me 14 times 6 is 64. So 64 square roots of 3. That would be the area of the triangular portion on top. So I had 160 cubic centimeters from the bottom, from this house portion, 64 square roots of 3 from the roof portion. I add those together. You know what? I'm just going to leave it like this. 160 plus 64 square roots of 3, and that would be cubic centimeters. That's an exact answer. If I wanted to go ahead and multiply that out, square root of 3 is square root of 3. It's 1.7 times 64, so that's about 110.8. Add the 160 to it. It's about 270.9 cubic centimeters, if I wanted to give an approximation. So hopefully these ideas make sense. I know that was a lot of examples. You got 30 minutes worth of videos that I asked you to watch for tonight. I apologize about the length. I don't like going that long, but like I said, more examples is probably better for this kind of a lesson. Be ready to do some homework problems related to this stuff when you come into class.